Okay, so in this video, I will discuss revision 3_1, question number 1. So whenever you get this kind of question, first thing you have to do is that you have to copy back the circuit lah. So once you copy back the circuit, always make the habits where you check whether numbers of resistors are the same, numbers of EMF is correct, everything, direction of current, everything, always double check. Okay, and then after that, the next step, normally what I'm gonna do is that I'm gonna highlight the current correspond to current 1, 2 and 3 with a different color. So example, this one I colored with yellow, green, and then blue for I3. The reason why I did this is that so that I can differentiate clearly that current that passes through this resistor is due to I1. That's an example lah. And then if I'm not too sure, you can always write like this is my R1 and this is my R2. And then after that, you can determine the direction of loop direction. And for loop direction, normally I will try to find from all these EMF which one is the biggest, and I will try to follow that direction. So this is the biggest one, so EMF direction, I will do it in this direction. Like that. Okay, and then since the middle one here, because this one shared for loop 1 and loop 2, like this is my loop 1 and this is my loop 2, and the middle part here share with both loop, so that means the middle one I'm gonna follow on the right hand side, so it will be upwards in the middle there, like that. Okay, so after that, you can apply the first rule, junction rule, where I in is equals to I out. So you have to select one of the junction first. So I'm going to choose this junction. So current going in, you can see that this is basically I2 is still in the green line, and this is I1. So I1 and I2 going in and I3 going out. I1 plus I2 is going in and I3 will be going out. Okay, this is the first rule that you apply. So this will be my first equation. And then the second one, I can apply loop rules. Let's say I apply for first loop. Okay, I can start with this one. You have two EMF, 6 volt and 4 volt. I can straight away write like 6 plus 4. Why it is positive? Because the loop direction is in that direction and it's going out from the positive terminal. So positive for that one, positive for that one as well. So 6 plus 4. Again, you can always label this one like EMF 1, EMF 2 if you want to. But I'm gonna straight away write down the numbers. And then for right hand side of the equation, you only have one resistor, which correspond to R1 there. The value for R1 is 7. Again, straight away I write 7. It should be IR. So I there is basically I1. So 7 I1. You can straight away calculate this one. It will be 10 divided by 7. So this will be 1.43 ampere. So it is positive, right? So that means our assumption of current direction I1 is the same with the actual one. Okay, loop 2, I apply the second rule. Okay, you have 2 EMF. This is the first one. Again, it's coming out from the positive using the loop direction, and this one going out from the positive terminal as well. So it will be positive 8 and positive 4. So I'm going to write like 8 plus 4 is equals to, on the right hand side you only have one resistor correspond to 5 ohms, so 5, and then current that passes through the R2 is basically I2, because that one is green color, right? Okay, now you can solve I2. It will be 12 divided by 5. It will be 2.4 ampere. And these two number, I1 and I2, you can substitute back inside equation 1. So I just rewrite equation 1. From equation 1, I1 plus I2 is equals to I3. So that means 1.43 plus 2.4 is equals to I3. So my I3 will be 3.83. Okay, so this one will be in MP as well. So I think if you want to write proper answer, maybe you can write down all the I's below here. I1, I2, basically you list it down. Oops. I3 is 3.83, I2 is 2.4, and I1 is, where's the I1? 1.43. Okay, that's it. Thank you.